Hello, everyone, and thank you for attending today's webinar, Accelerating Software Development Velocity with Clockwork and Incredibuild. Before we begin, I'd like to cover 3 housekeeping items for our viewers. First, at the bottom of your audience console, you'll find a number of widgets for questions and additional resources. When you have questions for the presenter during the webcast, click on the Q&A widget and submit your question. We will answer as many questions as possible at the end of the presentation. And if we run out of time, we'll get back to you via email. Second, if you need any tech support during the webinar, please use the help option. Third, and finally, a copy of today's slide deck is available in the resources section at the bottom of your screen. We will also email you a link to the recording of this webinar within the next few days. With that, I will introduce our presenters for today. Steve Howard, Product Evangelist for SAST tools at Perforce, joined by Eran Kinsbruner, Chief Evangelist, Senior Director, and Author at Perforce, and Yohai West, Senior Product Marketing Manager at Incredibuild. I will hand it off to you from here, presenters. Thank you for joining us on today's webinar.
Thank you, and everyone, welcome to this exciting webinar. I'm truly excited to have with me both Steve and Yohai from Incredibuild. We have a great agenda today for this webinar. We're going to talk about how you can meet the challenges of the modern software development by scaling your static code analysis with Clockwork, but also accelerating your entire continuous integration with code analysis with Incredibuild, and how actually you can power your entire CI/CD processes by combining these 2 tools with best practices. So with that, let's start with the static code analysis, and I would hand it over to you, Steve, to give us this intro.
Thanks very much, Eran. So yeah, first of all, we're going to talk about scalable static analysis with Clockwork. And first of all, what is static analysis? Let's start there. So the idea of static analysis, unlike dynamic analysis, of course, which is the alternative, is to perform some analysis, gather some data from our computer software without actually executing the program itself. So it's something we can generally automate pretty well. It's an automated examination of the software, and we can perform this examination prior to even running the program, or in some cases, building the program at all from the code. Static code analysis is where we're talking about analysis specifically, therefore, of the source code itself prior to it being built. And as we referred to in the introduction there, SAST, or Static Application Security Testing, is the idea of using this analysis specifically for the detection of security vulnerabilities or violations within our software. So kind of there's various topics there, but they're all essentially based on the idea of static analysis. For organizations practicing DevOps, static analysis is really an ideal piece to add into those cycles, and it's something that generally will take place in the create phase of your DevOps cycle. The idea being that as soon as the code is being created itself, we're able to analyze that code and the implications of the changes to that code, and therefore detection and remediation of problems, vulnerabilities or other quality issues or compliance problems is optimally left shifted in the cycle. Static analysis adoption is booming these days, and there's a number of reasons for this. One of them, of course, is this idea of the DevOps automation, where just maturity around the software development process itself is driving that automation and constant checking. For example, with the idea of DevSecOps, trying to increase our security within the entire development cycle, this is something we can automate using static analysis as part of that cycle with every commit and every change that we're making in that process. So that's one obvious place. There's also increased regulation these days. So, partly, I guess, in response to those increased demands for security, quality, reliability, whatever it is that we're, as our software development is maturing and possibly growing to larger scale, that regulation can also be required as part of the development process itself by using tools like static analysis to check that we're meeting the requirements. And the trouble is that obviously with complexity of software systems that we're seeing these days, in particular, it's really something where traditional testing methods perhaps are struggling to keep up with that growth in just complexity. Just taking an example, in the case of the Toyota electronic throttle control system, which became famous for some issues back in sort of the 2010 era. When they actually analyzed that, and they did some very in-depth analysis using some experts from NASA and so on, but when they actually looked at that, it really was apparent that the complexity of that software meant that when it came to testing it, it would have taken maybe 10 to the power of 8 hours in order to actually test that software thoroughly at the vehicle level. So in other words, at that level, the complexity of the software, the size of the system just became way too complex to practically test. And that's true of many other systems as well. As we have, embedded operating systems these days with 10 to the power of 80 or so different possible states. Well, that's something equivalent to the number of particles in the known universe. So we're talking about very, very big numbers in terms of those possible state transitions. It's phenomenal. So that is something where static analysis can really help, because it can do automation of those testing and trying to narrow down where the problems might lie, almost taking a risk-based approach to our testing and analysis. It can do that really, really well and really effectively. And that includes systems where they're growing rapidly, such as artificial intelligence, or even where we've got many, many platforms for a certain platform matrix of a product. But I mean, codebases are growing generally. Eran, I don't know if this is something you're seeing more widely, but certainly it's something we're seeing in the embedded space, as we see here.
Oh, definitely, Steve. I think that we are seeing, you mentioned earlier DevOps, and we're looking at continuous transformation and innovation throughout different verticals. Just in this slide, we see, the social media, we see airlines and mobile. So it's a bit outdated, but, the Android project, the open source project, is already over 25 million of lines of code. The Boeing software is over 14 million lines of code. So think about any code change that you're making that you want to validate, test, analyze, and ensure that it's safe and secure. Simply takes you longer because of this exponential growth of the code base sizes. So this is a huge and growing problem across verticals. It's not in a specific industry.
Yeah, no, exactly. And I think you're right. I mean, this diagram is actually from a paper by Andrea Busnelli in 2014, when he was looking at the state of modern high-end automotive systems growing so rapidly. But it's true. And actually, probably back in 2014, we didn't have the same connectivity in the world and the same, therefore, security concerns that we perhaps do now. And really to see these code bases like Android being so widely used and being over 25 million lines of code, as you say now, and that's growing quickly, it really is quite a big concern. So we have a bit of a problem here, really. And this is a problem also from an analysis point of view, not only traditional testing. We've already kind of realized that traditional functional-based testing has a limit to what you could actually achieve in a realistic amount of time for some of these systems. But even when we're looking at a very detailed whole program analysis engine, where we're actually analyzing every possible path through the codes, which is what we really want for that accurate and deep control and data flow analysis. But even that is starting to have a boundary when we're talking about some of these systems. In fact, if we're trying to perform this kind of analysis, there is really no comprehensive solution to do that completely. In fact, more formally, finding every single defect within a program of a non-trivial state like this is actually undecidable fundamentally from a mathematical point of view. So it is a very complex problem. And really, that's down to something we call the path explosion. Essentially, for these systems as they grow, the combination of those different paths through the system is almost growing exponentially. And that leads to rather large, complex search spaces for analysis tools. So we have a bit of a problem there, as we say. And really, why do we care? Well, as a developer myself, traditionally, it was wonderful. And the diagram here shows that whilst your system's building, you kind of got a little bit of downtime there, and once upon a time it might have been enough to look away for a moment. Later on, it might be enough time to go and make a coffee or a cup of tea. At some point, the compilation times and the analysis times become so huge that our developers are spending a large amount of time waiting, and that in itself is obviously a problem. So the good news is that with Clockwork, we've certainly found a way to kind of beat some of this problem. So essentially, from the perspective of static analysis and performing this advanced data flow and symbolic execution analysis, as we call it, it is actually possible to perform many of the components to that analysis actually in parallel on a unit-by-unit basis. And the way that that's done is essentially that we capture the data flow analysis and information for each module individually, and then store that information centrally, so that as we're then looking through the call trees, other methods and functions that we're analyzing when we're looking at the dependencies, we can actually pull that data directly at that point. So that really helps speed things up. And essentially what it means is we get two stages, that one following the other one. First of all, building out that data, and the second one analyzing it. But the point is that both of these two stages can then be run entirely in parallel, which is a wonderful thing, because it means we can really make use of that parallelization possibility within modern development machines and so on and so forth. So that's something that really helps us in terms of speeding up the analysis, the fact that we can parallelize so widely. And if we take an example here for a moment, we recently did some analysis of the Unreal Engine 4, which is about, I think, somewhere in the region of 4 million lines of code in total on version 19. The full data flow analysis, so if we're doing that analysis of every possible path through the system, essentially with all of the symbolic data for each step of that, and working out this deep interprocedural analysis, on a fairly standard development machine that we used here, with 8 jobs running in parallel, so an 8-core machine performing the analysis, it took around 24 hours, give or take. So this is okay. It's not brilliant. It's okay. It's something that, if we had an exponential algorithm rather than having that capability to parallelize, we really would be talking about weeks, months, or even years for the analysis to complete. So we've come a long way from the static analysis tools of old, essentially, by doing that clever data flow analysis. And obviously, it could be faster. So with Clockwork in particular, the defaults to up to 16 gigs of RAM per job. And also it can scale up to 64 way on a single machine. So if we had the resources available, obviously we'd be giving it 4 times the amount of RAM per core and up to 8 times the number of cores. Well, obviously each one of those multiplications generally decreases because of the parallelization. If we had 8 times the number of cores, we'd roughly divide the analysis time by 8. So we'd be down to about 3 hours. But it's still a big job, and not really suitable for something within a CI structure where you want fast feedback. So why should we want our static analysis to run faster? Well, first of all, continuous integration is cyclic, and every slow step or stage in that development cycle impacts the delivery time exponentially, effectively. So we're really building out that total time as a result of each step, and every second counts effectively in the work that we're doing. And if we can have these faster gated builds with every commit, for example, it means that we, just like with CI systems as a whole, the sooner we find out, the sooner we know there's going to be a conflict and we can roll back that change before we've even committed it into the master branch or whatever, the better it is. So early warning is essentially key. And faster static analysis, by the same token, does the same. The sooner we get the feedback to the developer that there is a new security vulnerability being introduced into the code stream, or there is a new violation of some standard, such as a code quality standard or even your own guidelines, that's going to have a compliance problem, again, it's vital to know early. So that's all the reasons why we would want to do it quicker and faster within our CI process. And of course, if we do have faster analysis, we can trade that off by perhaps performing more analysis or deeper analysis for the same time. And so again, for the same time in our process, we're getting even more data, more value from those tools. But it's easier said than done because, of course, we are limited physically to the number of cores and memory that we can provide with our static analysis machines. And even if we spend large sums of money on the most expensive, powerful machines that we can possibly have, of course, we're ending up potentially with machines that are then sitting idle for parts of the time as well. And so this is probably where Incredibuild is going to help us and coming to the rescue. So at that point, I'm going to hand over to Yohai to guide us through a little bit more of how static analysis and acceleration can be done with Incredibuild. Yohai, over to you.
Yeah, thank you so much, Steve and Eran, and thank you so much for having us on the webinar today, and really excited to show how we are working together to really accelerate this entire dev acceleration. And what I want to show you, just really get down to the basics of what Incredibuild offers as a general platform, take you through a scenario of both in a dev environment and a CI, talk a little bit about how this would work specifically in the case of static code analysis. And then we'll have a short demo, which will allow to see actually how it works in action. So let's start with what is a dev acceleration platform. Right here, what we're looking at is these two pillars. On the left side, what we do first is we dynamically and optimally allocate the best pool of resources that you have, because really that's where it starts. You need to know what is the power, the compute power that you have currently available in your organization. And that works both on-prem and also in the cloud, bursting to the cloud or full cloud. In other words, you have developers who are, let's say, doing less heavy tasks at the moment, or you even have build farms that are specifically available for just doing certain tasks, and you even have idle CPUs somewhere in your network that aren't currently being leveraged to the full potential. So first, we look out towards what network power that you have, both on-prem and in the cloud. And then what we do is we take each of the dev tool processes and we break those down into the microprocess level and execute those across those available resources that we have. And that includes both compilations, the CI testing, and static code analysis, which is, of course, the topic of the webinar today. What we've seen overall as the value that this brings in different scenarios is up to 10x faster builds, 80% shorter releases, going off the concept of shift left and the things that Steve had spoke about. The more that you can push more time for developers either to themselves test more, or to have a much more mature tested product handed over to QA is part of that. We've also saved, if you go back to that little cartoon that we all love, that thing is literally timeless, right? We can, I think, almost anyone can use that at any given time, and it's still true, and it's been used for years. And I think, as we saw before with the growing code bases and the code inflation, it's not going anywhere, disappearing anytime fast. But that's really what we're trying to help out with, is trying to reduce those that time wasted. And that time wasted, of course, translates into a tremendous value, whether it be buying back more time for your customers, your developers to be more productive, the better experience, or just time to market, or many other things that are included in that time saving. Context switching also is a great one, especially for us in a distracted generation that look more to be in the zone more than ever. Those even few minutes that you have that you need to wait sometimes can slowly snowball into anything that Taboola or any of those type of wonderful websites can grab your attention to start looking at. And in addition to that, if you think about those of you who have or thinking about moving to the cloud, some of either dev or your CI, because of where we sit and the concept of being in the process level, breaking those down, we also are able to reduce the cloud costs in helping you use cheaper machines, leveraging spot instances or the best mix of spot and on-demand to allow you to really get more compute power at a lower cost. And overall, again, as our topic concerned here is test coverage, which gives us a lot more room as you go faster. So let's break that down a little bit more. What we're looking at here is that dynamic pool of resources that, again, Incredibuild comes to manage, and that the element here is seamless. There's an agent that we call a helper that will sit on any of these resources, and it'll be seamless. And that what that will do is that, again, finds that unutilized on-premise compute power, or that can be in the cloud. And then basically, we are guaranteeing that you get the right power at the right time for the right price. Now, let's see how this now works with what we said in the beginning, which was first allocating that compute power, and now we're breaking that down into the microprocesses. So what we have here on a dev machine is our initiator, which will then speak to the coordinator, which will then decide what we need to now take in that dev process and break that down and spread those across in parallel. This is the parallelization across the multiple systems or the networks that you have. But really what the secret sauce here is that there is no need to set up any sort of infrastructure. It's the same code, your same tools, your same resources. So, if you think about in a perfect world where, you can do, the best standards and, the read, every book you have on how to write the best code ever, that is something phenomenal. And if you have legacy code, if you have other big millions of lines of code, to tell someone you want to now go into that and start tweaking things and changing things in order to get better performance is first very tedious, also can possibly be a risk, breaking something. And what Incredibuild does is it offers a solution where you don't have to go into that at all. It sort of wraps around your existing dev process and does that work for you. And again, at incredible light speed. So that's in a dev environment. Now let's take a look at how that would look in a CI environment. In this case, we have a Jenkins. So what Jenkins does great is that it can take, let's say in this case, a build that would normally take 2 hours. And what it can do is it can distribute that across other agents. And bringing that 2 hours down to 1 hour, which is, again, phenomenal. And that's probably why so many of the organizations out there are using CI, Jenkins, and so forth. Now, where does Incredibuild come in? Jenkins basically has, at the job level, that's the extent of where it can go. It can't go any further than that. So what Incredibuild does is that if you see here, the initiator was added to that agent, the Jenkins agent. And what that does is it breaks down into the microprocess level. So we started with 2 hours. Jenkins itself, or any distributed CI, can then distribute that to get that down to even an hour by splitting it across the nodes. But Incredibuild can take that, because it breaks down to the process level, take that down even to a number of minutes. So that's an example of how it could be used within a CI environment. Now let's look at how this kind of all comes together and sort of the work within the world of static code analysis and Clockwork. And as soon as we explain this, we'll head over to a short demonstration so you guys can actually see some of this in action. So first, what we see is in this context on the left side of the builds, general builds that the organization is working on, both incremental, full builds, or unit testing, all in which are processes which part of your cycle or your pipeline. Incredibuild is there to accelerate. Now, if you move over to the part of where Clockwork comes in and the process that it undergoes, let's see the value in how Incredibuild can help there. So first, you have the code build on the right. And what happens there is that Incredibuild can accelerate that code build itself, just like it does any other code build, But what happens here is that Incredibuild then brings out the trace output. That trace output, which is an important element of Clockwork, which helps then sort of give that list of what needs to be undergone in Clockwork itself. So extracting that towards the use in further in the flow in Clockwork. And then usually what happens is there needs to be another build, a Clockwork build. But Incredibuild makes it, though, that you don't have to do that build again, saving a tremendous amount of time in skipping over that additional build, and then ultimately getting to that stage of analysis, which is super, super important, where that, like any other dev process, Incredibuild can parallelize that, find the best resources, and accelerate that all in all together. So it's, Incredibuild sort of finds itself in multiple aspects of the code analysis process, which, seeing a lot of the results that we're getting from customers is absolutely amazing. And with that, I'm going to hand this over to you, Eran, so you can show us a quick demo on how this actually looks in the system.
Hi everyone. In this short video, we will see how using Clockwork and Incredibuild, developers can accelerate their entire build process while also running code analysis at scale. What we are seeing right now is that the Incredibuild build monitor tool allows the team to visualize in runtime the hardware resources that are allocated to the build process. In our case, we see that there are 8 cores being used on one single machine while the build is running. The Incredibuild solution realizes that there is a need to expedite the process, hence providing 2 additional machines, cloud machines, that boost the entire utilization to 15 CPUs on 3 different agents. This demo clearly shows how developers can reduce the time it takes to perform a build process on large code bases while running the Clockwork code analysis process. To summarize, Incredibuild allows developers to reduce wasted idle time and improve development efficiency and velocity. Incredibuild, as we've seen in the demo, automatically distributes machines when required, together with Clockwork that provides super efficient analysis algorithms that help keep analysis times linear and not exponential. With the ability to parallelize, developers can accelerate their entire CI/CD workflows, save precious times while getting faster feedback upon any code changes, and become more productive. Thank you.
Thank you, Eran, for that demo. And what you guys saw there was the build monitor, which is even within itself a refreshing way to visualize what exactly is going on in your builds. Many of you might, look at that through a command prompt. So being able to actually see that happening in a way which you can then further analyze any dependencies or within the process itself is, of course, greatly of value. So I think with that, that's sort of the tip of the iceberg as far as what Incredibuild can do in your overall dev environment, and specifically in static code analysis. And I think it's a perfect time to hand it back to you, Team Clockwork, so we can go through what we learned a little bit about today and wrap it up.
Sure, Yohai. Thank you so much. And I think that what we have learned up until now, we've learned that the power of combining both static code analysis with a build acceleration and efficiency platform such as Incredibuild really allows you to get both the accuracy, the speed, and the scale that you need to shrink down massive code bases compilation time to a very low amount of time. And this translates, as Stephen also Yohai mentioned earlier, to better productivity, faster feedback, the ability to identify and analyze large code bases so you can uncover security vulnerabilities, compliance and safety issues, and you can mitigate them faster in the feedback. That's kind of the shift left in DevOps that everyone is talking about, but you can really accelerate it to really huge amount of 10 times or even more. It's almost unlimited by utilizing both these tools. So I think that from a Clockwork perspective, you do get the accuracy, speed, and scale that you need. And I'll let you, Yohai, compliment, the key business values and benefits that Incredibuild builds on top of this solution, so you can, complement this method.
Sure, thanks, Eran. So first of all, it's important to remember that we are a dev acceleration platform, which means while it does, and as you hopefully saw, wonders to static code analysis, it's something that you would find useful throughout your dev processes. So it's something that would work both to compilations, to other testing, and other compute intensive types of processes out there. So it's not a sort of one tool for a single solution. It's a one tool for all, which is a big help in terms of the overall outlook on what you're investing in towards your helping push through your pipelines, and not just a single solution. In addition to that, as we saw, that again, got to go back to that cartoon. I'd like to one day not see it as saying that's a thing of the past and maybe hang that up in some museum. But for the moment, it's still, there is wasted time that could be something that can be utilized for more creativity that we're seeing with customers. Testing more, as we keep saying again, and overall, as the concept of developer velocity goes, a better experience. For more productivity, and for the programmers themselves. Overall, if you go now into sort of costs, from the IT perspective, it's a bit of a heaven sent, because again, it's because of the way that it is seamless and virtualized. You really don't need to do much. In other words, we like to say, in the amount of time that it takes me to explain to you how much this can save, you can already have run a quick trial on your systems and seen it for yourself. It's that seamless. And if for those of you who are going to or in the cloud, both or either your dev or your CI, there is again a cherry on top, which says that we can help dynamically and optimally use the right resources, whether it be spot instances or on demand, or the right mix, in order to save costs in your development overall, which is, of course, become a almost equally as important to many, especially in the IT world, when it comes to making things more efficient in your building. And that's pretty much, I think, where we stand. And I think right now we can move over to the final slide. Talk a little bit about what can our audience do now to learn a little bit more and to see how this can actually work in your environment. So at the moment, we have here options for trials. So again, seeing is believing. Definitely, like what I said, if you're able to give it a shot, it of course can work a lot towards understanding really how this works together. We have plenty of documentation that can help you through it, or of course we're here to help you through that. Two respective trials that you can also use promo code KWIB. Eran, do you have any thoughts on what we can tell our audience about the trials?
Sure. I think that we have the promo code here. We have the two free trials that our audiences can start playing with both Clockwork and Incredibuild, realize the value from both these tools. Just to mention, from a Clockwork perspective, it's agnostic to the major languages. So whoever is online that is doing development in C, C#, C++, or Java, soon also JavaScript, can start using the Clockwork for his security and safety compliance code analysis with Incredibuild. You have the Incredibuild.com free trial that you can download. You can learn more in the blog down below. You have the link, and you have also the slides in the resources panel that you can download and click on these links on your own in your spare time and learn a bit more about these two awesome solutions. We really encourage you to give it a try and give us feedback if you have any additional questions or comments on this content. And I think with that, prior to moving to the Q&A section, I wanted to stop and say, hey, thank you, Yohai, for partnering with us in today's webinar and delivering this amazing content. And thank you, Steve, for your piece in the Clockwork presentation. And we are ready to take any questions that you might have right now from the audience. Thank you so much. Connie, do we have any questions pending from the audience?
Yes, thank you very much, Steve, Eran, and Yohai, for the presentation here. I believe we do have a few minutes left here for questions. And our first question from the audience that has come in is, where in the development cycle would you recommend merging Clockwork and Incredibuild for build and SAST acceleration?
All right, I'll take that one. So that's a good question, Connie. Thank you. Yeah, so as Yohai explained, I think that obviously the Incredibuild platform is really going to support you through that whole cycle. So it is everything from the compilation and build processes, the unit tests, and so on, anything else you might do, as well as the static analysis piece if you're running that as well in your cycle, as we'd encourage. But very much, yes, the SAST piece, the static analysis, we'd recommend that being done as soon as possible in the cycle, because of course the sooner we do it, the sooner we get to know about the problems, and the sooner we can remediate those without wasting time downstream. And that's really a key point here. The sooner we do that, the faster we get that data to the developers, the sooner something can be done about it. So really the SAST piece or the static analysis for compliance or whatever else it might be, very much as soon as we commit would be the ideal. So as soon as any developer makes a commit to our version control system, we can trigger the CI job so we can detect the new issues entering the code stream at that point. And that really is the optimal time.
All right, thank you for that, Steve. The next question that I have here is, what are the requirements and process to integrate both Incredibuild and Clockwork in our development cycle?
Okay, well, when it comes to the integration of the two, I guess that's me again. So, well, actually, before this, I did a quick Google search, and actually the first article that comes up is actually the help pages from the Clockwork Online documentation, actually explaining how to run Clockwork within an Incredibuild environment and what's required to do that. It's actually relatively simple. It's simply a question of adding a command to the overall XG console within Incredibuild, and a profile for Clockwork to run within that. So profile change, sorry, within that. So yeah, it's relatively simple, but the documentation links are there in Google. So that's where I'd encourage people to go and have a look.
All right, sounds great. Thank you. The next question, can Clockwork cover both security testing as well as other compliances?
Yes, Clockwork can. Eran, I don't know whether you want to take that one, but certainly, from the security side, lots of coverage there. Eran?
Yes, yeah. I think that we didn't specifically listed everything that is supported, but from CER to CWE to AOSP top 10 and other specific compliances such as MISRA and AUTOSAR and other specific domain standards that are covered by Clockwork are fully supported by the product, so you can actually merge both DevSecOps security coverage as well as specific compliances for your audits. And at the end of the day, by the way, once you run them either from CI or locally from your IDE, you get a very detailed audit report for all of your compliances with all the detailed issues if you need to remediate remediate or fix them. But this product supports both security and safety and compliance standards. And we have all the details on our website, so you can go ahead and look into all of them.
Okay, perfect. Looks like we do have time for one more question. So the last one we have here is, what speed up could be expected of the Incredibuild acceleration of the Clockwork build?
Okay, I'll take this one, guys, because you've gotten 3 already, so I at least get myself in here a little bit. But yeah, so I think recently we had a test case where we got up to 6 times. But that said, it really depends on your environment, which means you can even go more. It's sort of like the more you throw at it, right, the more you can actually increase that. So it really is dependent on your environment, what you're running. And I guess it's just another call out to talk with us and see, let us help you kind of work through that easy assessment, and then set expectations for how you can even, go faster than that.
Great. Thanks for that, Yohai. Well, that is all that we do have time for today for questions. As mentioned before, if we didn't get to your question, we will be reaching out to you via email. Thank you to everyone in our audience for your attendance and participation today. And of course, thank you to our presenters, Steve, Eran, and Yohai. We hope to see you next time.